People often say that computers are very good at listening instructions. Computers always do whatever the users, the end users, the masters tell them to do, and on surface this seems to be true. By the way, first of all, when I say computers, it must include smartphones. Actually, I think the word smartphone is kind of a misnomer. It is no longer a phone because the origin of the word phone comes from the word telephones. And tele, just like the word television, tele means huge, long distance, and phone means voice. If I'm not mistaken, voice in a Greek or Latin word. So telephone means you transmit voices in a distantly, in a long distance. And today we all know smartphones. That is only a very very tiny subset of the function of a smartphone. A smartphone not only could allow you to transmit voices through a long distance, it could allow you to set alarm clock, it could become your watch or clock, it could become your calculator, it could become your video game console, it could become a camera, it could become your sound recorder, it could become a notebook, it could become your newspaper, it could become your television. For example, you surf on Netflix or YouTube. It could become your, yeah, I think that's pretty much right now a standard smartphone. So I regard smartphones as really computers. It's very similar to your desktop or personal computers. In the case that there are so many things they could do. So all these things only started after the advent of iPhones, and then other companies started copying it. And today, almost every single phone is practically a computer in a pocket size, a mini computers. So when I say computer, it includes that sense. Like smartphones are also computers. Okay, on surface, computers really follow whatever you say. So for example, when you press when you're setting an alarm clock, you are going to instruct a computer. Okay, you are telling it, okay, please ring a bell or at 8 o'clock a.m. tomorrow, and you could choose a ringtone. Please play this song at 8 o'clock a.m. And you could even set like the snooze button, how many minutes you want it to snooze whenever you press the snooze button. And tomorrow 8 a.m. it will for sure 100% it will ring without failing. And likewise, you could press a button and it will take a photo for you. It will follow instruction exactly, and it will save the photo in the storage. On surface, that those things seem to be affirming that computers always follow instructions. But however, when we say computers following your instructions, it is still very restrictive in many ways. Um, uh, okay, for example, I'm not too sure. Have you ever tried to teach a really old person how to use a computer or smartphones? Maybe your great grandmother, and it often seems very alien for them because, in general, okay, maybe in human context, when we say instructions, most of the time it actually means language, human language, and most of the time it means verbal. So, for example, an employer instructs an employee to do a certain task, a teacher instructs a student to do a homework, a parent instructs a kid to do some house chore. Um, so that is the general meaning when we use the word instructions. Hence, humans are very used to take it for granted. The word instructions and the word instruct actually means verbal communication. You tell another entity, and most of the time they are human beings. Although sometimes it might be a dog or a cat, but most of the times a human being. You tell him or her what to do, then he or she might execute it. This is what it means. And However, if you look at computers, things are very different. When we instruct computers, it is in a very subtle sense. It is in a very restrictive, tiny, narrow sense. For example, just now I said when you take a photo, you have to place your finger exactly on the button and press it, only it will take a photo. And of course, in your typical personal computer, you press a mouse, click, you press keyboard, then you have the instructions being fed into the central processing units. This is a general way, and therefore, for your great grandmother, when you try to teach them how to use computers, things seem very awkward at the beginning. Things is quite maladroit because their entire life they have not encountered any instructions other than a verbal form, or maybe sometimes it's just gesture, facial expression, but other than that, they have not experienced something so restrictive: mouse, touch screen, keyboard, and hence it seems awkward at the beginning. They don't really remember how to do it, and that is what I mean. The way humans instruct computers are still very restrictive. It's not as natural as human beings. Of course, I'm well cognizant that today, like Siri in iPhones, Alexa of Amazon, you could use a verbal language to instruct it. I have not personally tested all these devices too much. I've seen people just using voice to instruct your smartphone to open up the Waze application, and it will try to navigate you to the place you want to go. But however, I'm not too sure. First of all, how effective it is, aside from the standard English language, how effective it is for dialect, because locally, colloquially, people have a lot of weird words and languages. Could computers really notice it? I'm not too sure whether Siri and Alexa are only built in very standard formal languages, and hence it's worth trying whether a great grandmother would be comfortably using voice to ask computer to do whatever she wants it to do. Maybe take a photo, maybe upload a photo to Instagram, maybe to search on the internet on her favorite food recipe. I'm not too sure have we advanced to that level. It seems to be working. It seems that there are quite a lot of progress in this area. But generally, I still think that it is still not natural. Our instructions towards computer is still very restrictive in a certain modes. All of us human beings, as the end users, we still have to at least spend a short amount of time to learn the behavior of computers. How do we instruct it? That only we can master it. We can't easily use a verbal language or even just a thought in our mind and immediately computers could understand us. We still couldn't do that yet. All right. And if we look deeper in a more professional sense, in a programmer's level, it is even worse. Of course, programmers all understand that today they still have to be very, very precise in instructing computers via codes. It's always all the if else for loop, and you call library. You write functions. You have to be careful with the scope, the keywords. Otherwise, it will deliver bugs. And your software will be ruined. And that is even way more restrictive, in the sense that it's unnatural, and therefore I don't really regard humans mastering computer very well. I don't really regard computers fully listening the instructions to humans. In a way, computers are actually very rebellious. 99% of the time, it will not listen to you unless you really hit the exact keyword, exact things that computers could understand. And hence this would segue into the topic called compiler. So programmers know that when you write, let's say, 100 lines of code using a programming language, let's say JavaScript, you have all those if else for loop, while loop, and you assign variable, you could put arithmetic, all those statements, and return all those things. All those things seem on the surface to be quite understandable by a human being. It's still a natural language. It's still English, but however, deep down, actually, computers don't understand that, and whenever you want to run those kind of JavaScript codes, right, you actually have multiple layers of compilers to translate the language. It translates into assembly, and assembly translates into binary. But even binary itself is actually an abstraction for computers. Computers have no notion of zeros and ones any more than your table understands what is 0 and 1. It doesn't want understand, because zeros and ones are still an abstraction of human semantics. Humans try to semantify, I don't know whether there is such a word. Humans try to semantify and naturalize the idea of hardware. The idea of hardware is what? You let electricity to flow through, or you don't let it to go. And those two states, we try to naturalize it and to think that, oh, no, we try to give all these these two phenomena a notation. The notation is zeros and ones. When ones, it means electricity flows through. When zero, it means that it doesn't flow through. And hence, even when compilers compile all those binary codes, zeros and ones, computers still don't really understand, because deep down, computers, actually real hardwares, electricity, could only do a few things. It could have arithmetic logic unit to add things using logic gate. You can do basic addition, and then it could go to a certain coordinate of a hard disk and write the memory and change the memory on that place. And hence, actually, the entire business of computer programming could be reduced into very low-level axioms. The axioms are merely read memory, store memory, and addition. That's all. Basically, it's all these things. And you can see how boring, how mindless these three operations are. Alright, and therefore, very smart programmers, early programmers, actually try to create semantics of it. And just now, I said if else, all those if else, for loop, while loop, all those variable assignments, all those things, right, are actually semantics artificially created by humans. And in linguistics, maybe I explain a bit. In linguistics, semantics means meaning, and computers and hardwares generally have no meaning. However, when you have compilers, you could finally link the three rudimentary operations: read memory, write memory, and addition. You link it to human language: if, else, while, and for loop, and variable assignment, all those alphabets. So you have this vast distance between these two things: a very crude hardware thing and very human language things. You have compiler try to link them. So compiler does it carefully. A compiler does it carefully. It links if the word. Maybe I start. It links the word if carefully, using a very huge parsing tree of grammars, compiler grammar. It links it to the rudimentary addition, write, and read memory tree operations. Things are very complex in the middle, in how a compiler actually works, but that is the gist of it. So we have many layers of compiling, and even programmers, actually, most programmers, when they write codes, right, they are actually a human compiler in a way. They try to compile what end users, normal consumer who is going to eventually use the software, to try to compile whatever the end users think into JavaScript, into Python, and then of course they will now use another ready-made compiler to compile it to assembly, and assembly will be compiled using a ready-made compiler into binary. But however, in the very highest level, every single time when you press an alarm clock, and set it, actually there is a compiler. That means all the codes programmers have written, it will be compiled slowly at the end into binary. And that is how people add semantics to computer codes. But what is even more interesting, I want to look at human languages. I think human languages are the reverse. We have we are actually a semantics machine. Humans are semantics machine. I want to look at whether human semantics in our thoughts could be reduced into a few axioms groups or not, just like how computers could be reduced into 3 axioms, right? Writing and reading memory and addition. Could human thoughts that are initially endowed with semantics, could they be reduced formally into small groups or not? I will look at that and discuss that in another video. See you.